welcome back to Algebra 2 Honors, and specifically Chapter 6 on conic sections. We're going to finish up some hyperbolas today. A lot of the stuff you've gone through from your E-Day lesson on Tuesday, so this should go hopefully pretty smooth. Our objective here is to write equations in standard form and graph hyperbolas with centers at HK. So we started at 0, 0. Now we're moving around to HK, much to the surprise of no one, hopefully. Excuse me, but here we go. You've seen that slide before if you watched the other videos, so that's nothing new. This is really nothing new. New formula, new equation, now HK. We just moved it off of 0, 0. Nothing big there. That's old news. That's nothing new also. This is a vertical version, centered HK as well. Again, make sure the y is going. I always put my y first. I always put the positive fraction first. So be careful when you're writing your center about what that is. Don't switch around the K and the H. This slide is old news. This slide is old news. This slide is old news. So there you go. That's what where we're at. We're going to do the same thing we did yesterday, but the newest thing is we're going to put it into standard form. So doing that first, like we've done a lot of the other times, we're going to be completing the square, etc. But again, hopefully you picked up on the pattern by now. So here is our first example. So just as we did before, we want perfect squares. This by itself is a perfect square, but added with this negative 36x, this is not a perfect square, so we need to start off by making a perfect square. So let's do 9x squared minus 36x. Group my x's together, minus 4y squared minus 24y. Group my y's together, move this 36 to the other side by adding it. Now we need to complete the square. I'm going to factor out just the coefficient. 9 times x squared minus 4x plus a box minus 4 times y squared minus 6y plus a box equals 36. Now make sure we're careful with this. Another thing I need to change here, I factor out a negative 4, so this is going to change this to a positive 6y. So even when over here when I'm adding my boxes, it's going to be plus 9 times a box, but then I'm going to carry this sign as well, minus 4 times a box. That is extremely important, as that's going to screw up your numbers of what's going in the boxes and things like that. So we all know a 4 goes here and a 9 goes here, so a 4 here and a 9 here. This factors as 9 times x minus 2 squared minus 4 times y plus 3 squared. Now let's get rid of that. Make that a little cleaner looking. Y plus 3 quantity squared. Now over here on the right we have 36 plus 36, which is 72, minus 36, which gets us back to 36. That's pretty convenient. We want this to be equal to 1, as we have always done over the last couple of weeks. Divide by 36. Divide by 36, divide by 36. So our final answer here for the equation in standard form is going to be x minus 2 squared over 4 minus y plus 3 quantity squared over 9, again pretty convenient, equals 1. So there's our equation, and now from here is where we want to go through the process, vertices, covertices, etc., and you know, get all the information from this hyperbola and then sketch a graph of it as well. So let me rewrite this equation real quick of what we just had. We had x minus 2 squared over 4 minus y plus 3 squared over 9 equals 1. So I'll write some of the stuff out as we go along here. Let's start with the direction. We know that the x fraction is positive. So if the x fraction is positive, we know our direction is horizontal. And then we can go to our center next, where we're moving these around. So our center is at HK, so our center from this, be careful again, if you have a y first, is going to be positive 2, negative 3. So positive 2, negative 3 is right here as far as we're getting going on the graphing. A, B, and C matter. If this is my positive fraction, we know that a squared goes into the positive 1. I know 9 is bigger. That doesn't matter with hyperbolas. So a squared is going to be equal to 4. B squared is going to be equal to 9. A equals 2. B equals 3. So now with A being 2 and the direction being horizontal, that tells me I'm going to go left and right 2 units from the center. So left 2 units takes me back here, which is 0, -3 for one of my vertices. I'm going to label those. I'll label my co-vertices there. So I went left, got to 0, -3. I'm going to go right and get to 1, 2. That is at 4, -3. So again, I went left and right 2 units from the center, from that 2, and that got me to 0, -3, and 4, -3. Notice my -3 is the same in those. So now with my co-vertices, I'm going to go up and down. I'm going to go up and down 3 units from the center. If I go up 3 units, I get to 0. And if I go down 1, 2, 3 units, I'm at 2, -6. Those are my co-vertices. And as we have done, as we did last time, after we have those, I'm going to sketch a box around here that's going to help me in graphing with my asymptotes. So there's my co-vertices, there's my vertices. Let's find our foci while we're at it. We know c squared equals a squared plus b squared with hyperbolas. C squared equals 4 plus 9. C equals the square root of 13. Now, again, I want to see this. I'm not going to get out a ruler and measure on your graph, but radical 13 is going to be a little less than, is greater than 3, less than 4. So that is left and right from here. So greater than 3, less than 4, 1, 2, 3, there's 4, so somewhere in between there. 1, 2, 3, not quite to 4. There's my foci. And how I want those written, again, as they always are, there it is. My left and right, my x values are changing from the center. So when I'm writing that, it's going to be 2 plus or minus the square root of 13, -3. So there's my foci, my vertices, co-vertices, etc. Let's do the transverse length and our conjugate length. That says conjugate, right? And so our transverse length is 2 times A. 2 times A is 2, so that is 4. Our conjugate length is 2 times B. B is 3, so this is 6. Lastly, we'll need our slopes of our asymptotes. So let's go ahead and put our asymptotes in. So hopefully I can hit these pretty good. No, that was off. Let's try it again. There we go. That's pretty good. And there's another one that's pretty good. There's my asymptotes. So the difference from today from previously, now we have a different equation to work with. So our asymptote equation that I went over pretty quickly on those other slides is going to be this, is y minus the k value equals plus or minus a over b or b over a. And in this case, again, this is a horizontal. Let's count just to make sure. 1, 2, 3 over 1, 2. 3 is b, 2 is a. So when it's horizontal, it's going to be plus or minus b over a times x minus the h value. So now we have, there's our equation, and you have this from an earlier slide. Let's plug in what we know. Y minus k, this is my k value. Y minus 3 equals plus or minus b over a. 3 over 2 times x minus the h value from the center, x minus 2. And this is y plus 3, sorry about that. Y plus 3 because it's -3 here. I didn't sketch our graph. Let's go back real quick. Sorry, there's our, lastly, our parabola we need to sketch. I'm sorry, hyperbola we need to sketch. Follow your asymptotes. Make sure you're going through the vertice and not the focus. But there's what, that was a little curvy, but there's what that should roughly look like. So horizontal, opening left and right. There's your center, vertices, focus, co-vertices, asymptotes, and we're in good shape. So one more example of just, we're not going to go through all the way through this. Let's just put this into standard form. Again, we're looking for perfect squares. Ideally with this one, we already have a perfect square. Not with the x's, but with this y. So I'm going to group these x's together. 16x squared minus 160x minus 25y squared equals 0. So we just have to complete the square for the x's because 25y squared is already a perfect square. Pull out a 16, I'm left with x squared minus 10 plus a box minus 25y squared. Again, that's already a perfect square, equals 16 times a box. And what goes in this box here is going to be 25 here. So this is 16 times x squared, not even x squared, excuse me, x minus 5 squared or minus 25. This keeps messing up. 25y squared equals 16 times 25 is 400. So in standard form, I'm going to divide by 400. And this will also work out conveniently. 16 divided by 400 is 25, so I have x minus 5 squared over 25. 25 divided by 400 is 16. Y squared over 16 equals 1. So there's our equation in standard form, and we're in good shape. One last one, writing an equation of hyperbola. Things that still matter, things that will always matter when we're writing an equation. We need the direction. We need the center. We need A, B, and then possibly C. So let's start with what they give us. They give us vertices at 2, 3, and 2, 5. Here's 2, 3, and here's 2, 5. Unless it says anything about them being co-vertices, these are the transverse axis vertices, the actual vertices. They go with A. If these are on top of each other, our direction is vertical. That's a funky looking arrow, but up and down is our direction. Our center, again, if these are the vertices, I'm going to go down one here. I'm going to find the midpoint. The midpoint there is going to be, if those are at 2, 3, and 2, 5, my center is going to be at 2, 4. So we can start to write most of this. This is vertical, so y is positive. Y minus 4 quantity squared over something minus x minus 2 quantity squared over something equals 1. And again, this right here is 1 unit. This is also A. So A equals 1. A squared is also 1. So that's going to be positive. That's going to go under the y right here. What we don't have is anything about B. Let's go back up to the problem. Passes through this point. Hopefully by now you're picking up on this. If you have a point in xy in the equation, or in xy point that's not anything to do with the vertices, co-vertices, etc., you're going to plug that point in to my equation. So let's go ahead and put b squared here because that's what we're looking for. Now I have this 4, 0. Let's plug it in. So 4 for the x, that goes here. 0 for the y, that goes over here. 0 minus 4 squared over 1 minus 4 minus 2 quantity squared over b squared, we're looking for b squared, equals 1. 4 squared is 6, or negative 4 squared is 16. 16 over 1 is just 16. 16 minus 4 minus 2 is 2. 2 squared is 4 over b squared equals 1. Move the 16 over, so I have negative 4 over b squared equals negative 15. I'm going to solve this now. I get negative 15. B squared equals negative 4. B squared equals 4 over 15. So again, I don't need B because B over squared is sufficient. That's what we're looking for right here. So when I plug this in, I'll plug it in twice. Let's move some stuff around here and clear some space. So when I plug that in initially, it's going to look like this. Y minus 4 squared over 1 minus x minus 2 squared over 4/15 equals 1. But you guys don't like fractions in the bottom of a fraction, and nor do I. So let's move this around. I would just work with this fraction. I would rationalize it, and so it becomes this, y minus 4 quantity squared over 1 minus 15 times x minus 2 quantity squared over 4 equals 1. So there is our equation. There's what we're looking for of our equation of our hyperbola, and we're good to go there. Again, thanks for tuning in. I think I was at 52 subscribers at the beginning of this. If I get 60 subscribers by the end of Thursday, March 19th, I will put a bonus on that will count for points on the lesson check quiz. Make sure you clickety-clack that like button, get that subscribers up past 60, and we'll see you next time.